Okay, so the definition of Doppler effect, if you look at your lecture note, is actually something like this. It's defined as the change in the apparent frequency of a wave as a result of relative motion between the source and the observer. Okay, so sebenarnya dia ada beberapa keyword over here. One is about apparent frequency, and then dia kata motion between the source and the observer. So because of the motion between yang mengeluarkan frekuensi itu dan yang mendengar frekuensi itu, source and the observer, there's actually apparent frequency. Change in the apparent frequency means apa yang didengar tu bukan yang sebenarnya dihasilkan. Contohnya, katakan saya hasilkan 100 Hz, tapi yang didengar tu maybe 120, maybe 80. Those changes, the difference tu because ada pergerakan, sama ada source ataupun observer. Faham ke tidak? So, apparent ni apa yang didengar, tapi tak semestinya yang dikeluarkan. So, ada beberapa benda penting, saya tulis dia punya ni. So, we use FA to represent apparent frequency. Okay. Ini frekuensi yang didengar dan yang didengar lah. So, frekuensi ni, bila frekuensi tinggi, biasa kita kaitkan dengan apa? Macam physical quantity, kadang-kadang kita oh, orang tu menyanyi dengan frekuensi tinggi. Maksudnya apa? Adakah suara dia kuat? Okay. So, common misconception is about dia punya volume, which is kuat tak kuat lah kan. Orang selalu fikir bila frekuensi high, volume high. But no, it's something not related actually. Intensity of sound yang kita belajar dekat 10.3 is actually represent the volume. Lagi kuat, lagi tinggi sound intensity. But here we are discussing about frequency. So frequency actually lagi kuat, lagi tinggi dia punya kenyaringan. Macam high pitch. Faham ke tidak? So high frequency nyaring, low frequency kurang nyaring. You guys understand that or not?
Faham, sir.
Okay,
Faham,
so I
sir.
just write down over here. High frequency means more nyaring lah. Senang nak faham kan? So low frequency, opposite nyaring apa kan saya tak sure. Kurang nyaring. Macam jerit, nyaring tak jerit tak nangis kan. Kalau baby nangis kadang-kadang nyaring, kadang-kadang tak nyaring. These are the thing, the frequency. And then we have apa dia? Source dengan observer. So kita ada few velocity yang main peranan. Satu, VO. VO here is velocity of the observer. Okay. Katakan saya selaku pendengar bergerak selaju 5 meter per second. So that is my velocity of the observer. Katakan saya berhenti. So my V will be V equals to 0. Itu adalah velocity saya lah bila berhenti. And kalau yang mengeluarkan bunyi, itu kita panggil V source. So normally in example dia pakai kenderaan yang mengeluarkan bunyi. Contohnya macam ice cream truck yang bercakap. Ice cream truck tak nampak sangat. Maybe ambulance, fire truck ataupun fire engine, police car. So those kind of thing that ada bunyi sirens tu kan. So bila dia datang, dia bergerak, that one is velocity of source. Okay. And then we also have F. F here is the source frequency. So the actual frequency lah yang dikeluarkan. And then we also have apa gitu? Saya tulis formula dia dulu. Oh, lagi satu kita V. V yang tak ada subscript tu adalah velocity of sound. Velocity of sound ni dia constant. It depends on the temperature actually. It will be given inside the question. Sometimes it varies a little bit. Maybe I can put this one as 303, but this one just an example lah. Example. 303 meter per second. Okay, so we have a formula. If you look through your formula sheet, this one is actually under formula 58, okay, where FA is equals to V plus minus V naught, okay, over V plus minus Vs multiplied by F. Okay, so the symbol that we use, I already define it on the right hand side ni lah, yang tadi yang FA tu semua tu saya dah define. Okay, each one of these ada maksudnya. And then one thing yang saya nak kamu ubah, whenever you get the formula sheet ataupun bila kamu nak jawab soalan tu, I strongly suggest you to flip plus minus yang dekat bawah ni, dekat denominator tu. Kalau formula asal dia, plus tu dekat atas, minus tu dekat bawah. So I just want you to flip negative and positive. Okay, so this one actually similar to the lecture notes kamu. Dia pakai yang macam yang saya tulis ni. And then saya akan explain sekejap lagi kenapa perlu terbalikkan. Okay, for now, any question? Soalan tak?
No, sir. No, sir. Lagi.
So, setiap satu simbol ni represent benda-benda ni lah. FA tu ni, V0 tu ni, Vs tu ni. And then F is the source frequency and V is actually the velocity. Okay, so in terms of, katakan saya nak lukis something lah, saya nak tulis, let's say I want to try to represent in terms of diagram. Katakan saya ada ambulance. And this ambulance is moving towards you. Okay, so kalau kita nak label all these symbol into the diagram, the FA is the apparent frequency. Itu yang didengar oleh this person. Okay, FA itu correspond to the frequency that is being heard by this person lah. The velocity of the observer means the velocity of this person. Kalau dia tak bergerak, V dia berapa? Kosong, yes, correct. Okay, and then we have Vs, velocity of source. So if this ambulance is coming towards you, then we will have Vs. Okay, and then source of frequency, katakan dia adalah F tu, dia datang daripada sini lah, daripada sirens to itself. Dia adalah the actual frequency that is being produced. Okay, dia berbeza dengan apa yang didengar lah kalau ada pergerakan antara dua tu. Okay, and then we have V, which is velocity of sound. That one is a constant. So speed of sound. Okay, so now let's try to think something that is logical. Something that is logical lah. Katakan kamu tengah standing, okay, and then you have an ambulance coming towards you. So ikut logik, kamu rasakan semakin ambulance tu mendekati towards you, does the frequency increase ataupun decrease? Adakah frekuensi itu naik ataupun menurun? Menaik kan? So sebenarnya ada dua benda yang kamu kena perceive lah. Yang pertama, bila kamu observe ambulance coming towards you, you sebenarnya dengar dia makin kuat. Okay, those makin kuat tu because of the sound intensity, which is represented by the relation 1/R. Kalau kamu ingat lagi lah. So the closer you are, that means dia punya intensity tu lagi kuat. So it makes sense lah bila ambulance tu dekat dengan kamu dengar dia lagi kuat. Tapi something that is not too obvious is that the frequency bila dia mendekati kamu actually higher. Kamu dengar pitch dia tu high. lagi nyaring. And bila dia keluar, dia jadi less nyaring. And in fact, dia punya relation tu sebenarnya adalah constant. Okay, contoh I can represent the relation to something like this. Okay, jadi saya akan explain more on this lebih detail. Tapi saya nak tunjuk bila dia mendekati, which is this is the person, katakan kita punya position x equals to 0, this is the person, and ini adalah positive x, negative x. So katakan dia mendekati, so over here you have frequency that is higher compared to the f yang sepatutnya. Okay, but then bila dia keluar, bila dia moving away, you will hear that the silence is actually has a lower frequency, and the reason because of the Doppler effect. Okay, so kalau kamu dengar dia lagi kuat, dia lagi nyaring, kamu pakai yang atas ni. Okay, pair yang atas ni, positif, negatif. Faham tak? Kalau kamu dengar dia less nyaring, you use this one, negatif, positif. Boleh tangkap tak? Can you understand?
Kurang.
Kurang. Okay, yang ni saya nak tunjuk ni adalah penggunaan formula. So this one, you have to use pair yang saya bulatkan yang biru ni. Okay, bila frekuensi apparent bigger than F. So kamu dengar dia lagi nyaring. Macam mana nak tentukan dia lagi nyaring ke tak nyaring? Kamu fikir logik. Kamu ada ambulance coming towards you, ataupun kamu berlari ke arah ambulance, so by logic you will expect that frequency to be higher. Betul tak? Betul tak?
Betul.
Okay, so bila higher frequency, kamu ambil pair yang biru tu. Kamu pakai simbol tambah dekat atas, minus dekat bawah tu. Okay, tu one thing. Kalau let's say kamu punya two situation berubah, the ambulance now moving away from you. Okay, so you have FA less than F. Kamu dengar frekuensi dia lower compare to the actual one, ataupun kamu berlari away daripada source itu. Now kami ambil pair yang bawah sini. Faham ke tidak?
Faham.
Faham. This one is about penggunaan formula lah. So you think about logic. Mana satu yang logic, and then once kamu dah decide, okay, dia higher frequency by logic, so kamu ambil pair yang atas. Kalau yang less, kamu ambil yang bawah kalau less frequency. Okay, that one biasanya dalam syllabus kamu salah satu je bergerak. Contohnya observer bergerak, source berhenti. Source bergerak, observer berhenti. Tu biasanya syllabus kamu dia tanya pasal tu lah. Tapi kadang-kadang dia boleh tanya what will happen if these two is actually moving, and katakanlah kamu berlari ke arah source, kamu kejar ambulance. So bila kamu kejar ambulance, that action increase frequency ke lower in frequency? Kalau kamu mengejar ambulance, ambulance tu source dia. Adakah kamu menaikkan frekuensi, menurunkan frekuensi?
Kalau kita kejar dia, naik frekuensi.
Naik kan? So kamu ambil yang atas ni lah. Tapi sekarang dia kata ambulance pula lari away from you. Dia takut nampak kamu, dia lari. So ambil yang atas ke yang bawah? Frekuensi menaik ke menurun? Bila turun kan? So kamu kena ambil yang bawah. Okay, so ada certain cases yang kamu boleh ambil atas dengan bawah ni, tak semestinya biru-biru, kuning-kuning. Kamu boleh ambil biru-kuning. Tapi jarang lah ada orang tanya. Biasanya salah satu sahaja yang bergerak. So normally we just use this one for increase in frequency, and this pair for decrease in frequency. Okay, let's look at an example. Okay, by the way, Azmin ada. Saya dapat macam Azmin baru masuk. Dah tak ada dah?
Kelas pagi tadi pun tak ada.
Tadi saya nampak dia masuk. Tak ke?
Tak Dia kot. Masuk asa.
Saya nampak.
Lepas tu, dia keluar. Ni Azmin. Apa cerita Azmin? Hello? Are you there? Azmin? Ada tak?
Ada ke dia sir?
Ada. Muhammad Azmin.
Oh adalah. Rasa.
Tapi dia tak menyawa.
Tak tahu.
Azmin? Adakah kamu mendengar? Okay, jadi saya panggil dia lagi. It's okay. Okay, now let's try to look at situation yang mana kamu boleh tengok dengan lebih jelas lah. Hopefully lebih jelas. Okay, katakanlah kamu you're sitting tengah makan nasi lemak dekat kedai mamak. Okay. Warung tepi jalan lah. Okay. Okay, tengah kamu duduk-duduk ni, tiba-tiba ada accident dekat ujung sini. Okay, so a car hit a tree, katakan dia langgar pokok. Okay, so now somebody call the ambulance. Okay, and then sepantas kilat ambulans pun datang. Okay, so bila ambulans ni datang, sekarang ni kamu bergerak ke tidak? Kamu tengah makan nasi lemak tadi. V kamu sama dengan?
Kosong.
Zero.
Kosong.
Tangan je bergerak kan, tapi kamu tak bergerak lah. I mean, body kamu tak bergerak. V ni kamu nak label V apa?
Be observer.
Yes, VO lah. V observer O ataupun V not lah kita panggil. Okay. And then kita ada ambulance ni coming towards you. So ini V apa?
VS.
Yes, V source dia. Okay. So kalau situation macam ni, ikut logik, kamu punya frekuensi yang didengari oleh kamu tu, is it higher or lower?
Higher.
Yes, very good. So the apparent frequency would be higher compared to the actual frequency, the source frequency lah, F kat sini. So this one is for case A. Okay, katakan for case A. So in terms of equation, so kamu dah understand the situation. Now you already decided that the FA will be bigger than F. Now you want to choose the formula. So the general formula is FA equals to V plus minus V naught over V minus plus Vs. Yang saya flipkan yang bawah tu, this is F. Betul tak? Okay, betul. And then kalau case macam ni, yang case A ni, kamu nak pakai pair yang atas ke pair yang bawah?
Atas.
Atas sebab benda kalau kuat. So basically you want to use this pair. Okay. So because of that, therefore for A, your equation now becomes FA equals to V plus V naught over V minus Vs and then F. Okay, and remember your V naught now is equals to 0. So this one is 0 lah. So this would be your equation. You just have to substitute the values. So V tu berapa? 330 contohnya. Vs tu katakan 5 meter per second. Then you substitute 5 and then F tu berapa. So the V here, normally they will give you in terms of meter per second. Okay. Sometimes they might give you the speed of the ambulance in kilometer per hour. So you have to make sure the unit is the same. Biasa kita convert kmh ni kepada meter per second lah. So that you can substitute inside the formula and you get the final answer in SI unit which is in Hertz. F di dalam Hertz. Okay, that one is for the first situation. Now let's say the ambulance now dah pass through you. Dia dah lebih daripada kamu. Dia dah melepasi kamu. Now dia somewhere over here. Dia still bergerak and still moving away from you. Now it's moving away from you lah. Situation B. So in this case, do you expect the frequency to be higher ke lower?
Lower.
Lower, okay, very good. So now, you as the observer will hear that the frequency is lower when the ambulance now moving away from you. Okay. So the equation now, kamu nak pakai yang atas ke yang bawah? Bawah?
Bawah.
Bawah lah kan. So obviously you have to use the bottom one because they dah moving away. So now your equation becomes FA equals to V minus V0, ambil yang bawah tu, V ambil yang bawah plus Vs. Okay, understand or not?
Faham.
Faham ya? Okay, good, very good. Okay, now let's continue with the story lah. Okay, katakanlah okay, ni cerita tadi. Katakanlah ambulans ni dia dah berhenti kan. So now the ambulans is stop. Dia tengah merawat, ada apa tu, MO tengah merawat the patient lah dekat situ. So your VS kalau dia berhenti, maksudnya VS dia sama dengan 0 lah kan. Okay, now you are being like a typical Malaysian, you want to see what happened. Okay, tadi kamu tak nak pun, tapi sekarang ni dah ada orang ramai, you start to wonder lah apa yang berlaku. So you want to see what happened, so you run towards the ambulance. So if you run towards the ambulance, your action tu adakah menaikkan frekuensi ataupun menurunkan frekuensi?
Naik.
Naikkan frekuensi. Okay, so this is U, VO. So this action basically makes FA bigger than F. So kalau ikut logik, if I still choose this equation, kamu nak pakai pair yang atas ke yang bawah?
Atas.
Atas, okay. So I think by now you guys understand kot apa yang sebenarnya perlu buat. Senang je sebenarnya. Okay. So if I choose the atas one, kita nak A lah, ni C lah. Okay, so now your equation becomes FA equals to V plus V0 divided by V minus Vs. Okay, multiply with F. Okay, that one is for C. Okay, let's say now kamu dah sampai, kamu nampak pula orang ni, dia dah keluarkan and then dia banyak darah. So and then you get scared. Okay, so what happens is that kamu lari balik ke nasi lemak kamu. So your action now, what will happen with the frequency? Naik ke turun?
Turun.
So because you're moving away, okay, sebelum saya terlupa, VS tadi sama dengan 0 sebab ambulance tu tak bergerak. Okay, now you are moving away, so frekuensi menurun. Nak ambil pair atas ke pair yang bawah? Bawah. So V minus V0, V plus Vs, bracket F. Vs masih lagi 0 sebab sekarang ni source dia tak bergerak. Okay, faham ke tidak?
Faham.
Faham Okay, soalan ni biasanya mark ada maybe 2. At most maybe dia letak 4. And then 4 tu biasanya include the diagram. So diagram dia macam yang tadilah graf yang saya tunjuk tadi. Dia walaupun markah sikit tapi senang dapat. Tapi make sure kamu faham lah. Kalau tak faham memang tak dapat markah tu. Sayang lah. For me it's easy. So X, positive X, negative X. This is when X is equals to 0. Okay. You have a point over here that represent F yang source tu punya frequency, and then you have frequency when it is coming towards you, and you will have frequency when it is moving away from you. Okay, biasanya dia akan suruh kamu kira dulu. Kira frekuensi dia semua tu. Yang tadi tu kan, bila orang tu datang, bila orang tu pergi. And then you will get 2 values lah. And those value, kamu kena label over here. Let's say I put 1 and 2 lah. Mana yang lagi besar tu lagi tinggi. So this one represent the frequency that is being heard, ataupun frekuensi lah, by the observer. Okay, so if you draw the shape correctly, something like this, most likely you get 1 mark. And then if you label everything correctly, include the title there, and then kamu label nilai ni, and then you should get another mark. Okay, so I think at most they will give you about 4 marks lah for this one. Okay, let's try to look at the example. Question number 17. Cuba baca dia. We try to read the question. Try to think whether you have increase in frequency ataupun lower in frequency. Okay, in the meantime, Azmin ada? Azmin, please respond. Okay, dah baca belum soalan?
Dah, sir.
Okay, a boy is standing at the bus stop. Okay, saya tak tahu kenapa yang kecil-kecil saya confuse bus stop dengan bus stand. I don't know why. So let's say you are at the bus stop. Okay, and then you are here, you're standing there. And dia kata when a fire engine with a velocity of 40 meter emitting siren with frequency okay, pass through him. Calculate the frequency heard by the boy when it is approaching him and when it is moving away from him. Oops. Okay, kamu ada fire truck that is coming towards you. Okay, this is not ambulance, this is fire truck. Satu dia towards you, satu lagi dia away from you. So yang untuk soalan A, 17A, dia kata is approaching him, that one is actually and this one, A. Okay, and when it's moving away, it's actually that one, B. Agree ke tak?
Agree.
Okay. How about the velocity of the boy? V dia sama dengan berapa?
0.
0. Okay, V ni V apa? Kamu nak label V apa? V ke, V0 ke, VS?
V orang tu V0.
V0. Okay, V orang is V0. A boy standing, okay. Yang velocity yang 40 ni, V apa?
VS.
Yes. VS dia adalah 40. Masa dia datang, 40 meter per second. Masa dia pergi, adakah berubah?
Tak.
Tak, sama sebab dia the whole journey dia bawa 40 meter per second. Maybe to top speed dia kot. Okay, and then they emitting a sirens with a frequency of 550. Okay, itu dia punya apa?
Frequency.
Nak kasi berapa 550 tu?
F.
Adakah F ataupun FA?
F.
F. Kalau dalam nota kamu dia pakai F0 dengan FS kot kalau tak silap saya. Tapi saya ikut ni ikut kamu punya formula sheet, which is something that you will get in exam lah, which is better lah. Yang FS dengan FA tu lama punya syllable. Sekarang letak di dalam formula dia tak ada symbol tu. Tapi sama je sebenarnya. Okay. So F ni adalah source punya frequency. Okay, let's try to solve question A and B. So for question A, just want to copy down the equation here. Okay, untuk action A, does the frequency increase ataupun decrease?
Increase.
Increase sebab apa? Sebab kamu punya, bukan kamu punya, the fire truck ataupun fire engine is actually coming towards you. That action increase the frequency. So kamu nak ambil pair yang atas ke yang bawah?
Atas.
Atas, okay, good. So the velocity is not given here, velocity of sound. So I just take from the next question. I think it will be 330. Okay. So it will be, tadi saya ada tu dah kat atas ni, berapa? 303, okay, saya tukar lah ni. 303 kecil sangat, 330. Okay. Kalau dia kasih nilai lain, kamu ikut je nilai dia. So the V here is 330 untuk V. Ambil pair yang atas, so it will be plus, yang bawah ni negatif lah. V0 dia sama dengan 0 sebab the person is actually stationary, the observer is stationary, and then Vs is equal to 40. Okay, if you substitute inside, sorry, if you calculate what value of F you will get, jangan lupa untuk darab dengan F tu, kat belakangnya ada F kan. So F tu sama dengan 550. Okay, so you still have to multiply with that 1. Okay, so dapat berapa ni? Question 17A.
Mana saya dapat 330 tu?
Saya ambil daripada soalan seterusnya. Dia sepatutnya diberi lah. Sepatutnya dia memang beri dalam soalan ni. Sebab dia tak kasih. So saya korek kat sebelah lah soalan yang seterusnya. Tapi itu adalah constant untuk sound wave. Okay, dapat apa?
625.86.
Okay, 625.86 Hertz. Very good. Okay, hopefully others will get the same value as well. Okay, moving on to the B. Now the fire engine is moving away from him. So this action, does it increase the frequency ataupun lower down the frequency?
Lower down.
Lower down the frequency. So nak ambil pair yang atas ke yang bawah?
Bawah.
Okay, good. So FA equals to 330 minus 0 sebab dia tak bergerak. V plus source which is 40. And don't forget to multiply. So ini tak kisah kamu buat square bracket ke curve bracket ke, tak kisah lah. Okay, multiply with F which is 550. Okay, this one equals to
490.54.
419. 90.
90.
Good, very good. Okay, yang lain dapat sama.
Dapat sir.
Okay, so these two values, katakan dia suruh lukis graph to represent the situation. Sekarang ni dia tak suruh, tapi katakan dia suruh. Apa yang kamu boleh buat adalah pertama sekali kamu label 3 benda. Okay, kamu dah label ni kan? Ni axis dia. And then you label 3 things. Number 1, the frekuensi yang tinggi, frekuensi yang sepatutnya, dan frekuensi yang rendah. Okay, so yang sepatutnya, yang asalnya frekuensi dia yang dikeluarkan oleh fire truck 150. Okay, yang didengari higher tu bila dia datang tu is actually 6 to 5. 6 to 5.86 ni didengari bila dia datang, and then you have 490.54 bila dia moving away. So then once you label, kamu boleh buat dia punya graph. Okay, jom saya naikkan sikit. And you just have to connect between these two lah. Okay, ini kalau dia suruh label, and you just have to draw the arrow. This one indicates dia datang, dia pergi. Macam tak? Okay, titik tu saya tak samakan lah, biarkan dia belakang situ. Okay, any question for question number 17? Ada soalan ke tidak?
Tak ada sir.
Okay, kalau tak ada, kita pergi ke question 18. A sound source which can produce sound of frequency 300 move away from a stationary observer. The observer notice that the frequency of the sound change by 10 when the source is moving away. Okay, sekarang ni the moving away, saya ambil situation tadi. Okay, the observer still stationary. And now dia kata the sound source is moving away. The observer noticed that the frequency of the sound heard by the changes by 10 Hz. Determine the speed of sound of the sound source. Okay. So now the key thing here is that you want to find the frequency that is being heard by this person, which is FA lah. Cari FA dulu. Okay. Yang dia beri itu adalah F. Okay, now I want to ask you guys, F dia tu bertambah ke berkurang kalau situation macam ni? The fire truck now moving away. So F dia increase ke decrease?
Decrease.
Decrease. So yang kamu dengar, so katakan kamu nak kira, dia kata decrease. Okay, decrease by berapa banyak? Yang asal adalah 300. So yang kamu dengar kurang kan? Kurang sebanyak berapa sebenarnya? Dan soalan dia cakap sebenarnya, kamu kena baca soalan dia.
10.
10 dia kata the observer noticed that the frequency of the sound heard changes by 10 Hz. So maksudnya macam ni lah kalau kamu nak in terms of mathematics. Change in frequency, which is frequency minus dengan apparent frequency is 10. Okay, ada beza. So this would be 290 Hz. This is the apparent frequency. Now you have the apparent frequency and you do have the F. Maybe you can find the remainings lah. Soalan dia nak cari VS. Okay, dalam situation kamu, dia tanya balik frekuensi menaik ke menurun?
Turun.
Kes ni, frekuensi naik ke turun?
Turun. Turun.
Kalau turun nak ambil pair atas ke pair bawah?
Bawah.
Okay, good, very good. So if you take this one, so you left with FA, which is 290 equals to 330 plus V naught ada berapa?
0.
Okay, good, very good. V naught is 0, and then we have 330 minus, this is the one that we want to find, right? We want to find the VS multiply with 300. Okay, you can do this one by one or straight away multiply together. It will be 290 divided by 300. Okay, and then you have to bring 330 yang kat bawah tu naik atas. Ni kalau kamu nak tekan satu-satu lah, obviously you can straight away press your calculator. Make sure the bracket is correctly done inside your calculator. If not, you have to do it one by one lah. So here I got 319.
Sir, frekuensi dia menurun kan?
Frekuensi dia menurun, betul?
Yang sebenarnya formula ni dia guna atas.
Alright, very good, very good. Okay. So this one sepatutnya yang oleh yang saya bulatkan tu lah. Kan? Negatif, positif. Is it correct?
Yes, sir.
Okay, so saya buat naik atas jadi positif. Okay, very good. Thank you. So this one 290 divided by 300. I got 0.967. Yes. So 330 divided minus 319 divided by 0.967. I got 11.38. Okay. Obviously, kalau kamu tekan calculator, the values might differ a little bit due to the rounding off over here. And then kalau kamu rounding off dekat sini, pun nilai kamu akan berbeza sikit, tapi tak kisah. It doesn't matter. As long as you press your calculator correctly, then all answer is acceptable. Okay, any question on question number 18?
No, sir.
Okay, if there's no question on 18, maybe we can try to discuss one more. Which is question 19. The siren of ambulance at rest emit a predominant frequency of 1005 Hz. What frequency will you hear if you are at rest and the ambulance move at 26 meter per second towards you? So ini situation yang kalau dalam gambar ni kan, A ke B?
A.
A, okay, very good. Let's copy this one. Let's paste it over here. So dia kata ambulance to moving towards you. Dia kasih tak? Dia kasih speed dia which is 26. So pardon saya supaya kamu tak confused. Okay, dia kata the ambulance is moving towards you at the speed of 26 meter per second. Okay, and then bila dia dekat rest, bila dia tak bergerak, dia emits 1500 Hz. That one is your F. What frequency will you hear? So they want you to find the apparent frequency if you are at rest. So V naught is equals to 0. Kamu tak bergerak. Yang bergerak adalah ambulance and towards you. Okay, in this case, adakah frekuensi menaik ke menurun?
Naik.
Naik. So naik atas ke bawah?
Atas.
Okay, very good. So I'm going to take that one. So now your equation becomes FA equals to 330. This is given inside the equation as speed of sound in air plus V observer is equal to 0 divided by 330 minus dengan source. Don't forget to multiply with the original ataupun yang asal punya frekuensi. You have 330 minus divided by okay, dapat apa ni?
$1,628.
Okay, dapat sama tak?
Sama.
Okay, good, very good. Okay, ada soalan?
Tak ada.
Tak ada Okay, that's it about the Doppler effect. Memang senang, memang simple, dia tak susah pun. It's just that you have to draw and then you have to use the equation correctly. There's no shortcut really. So just lukis betul-betul, and if you understand, then it shouldn't be a problem. Okay. Now I just want to go back over here. Okay. And I just want to do one example, which is question 14. Okay. So hopefully after this you can try to do question 15 and 16. And you can do all the previous question yang before kita discuss today lah. Tadi kita dah discuss soalan ni, tengok buat soalan yang mana-mana kosong tu, and then maybe tomorrow we will discuss the remaining of the question. So this week kita habis chapter ni. Okay, question number before we go to question 14, I would like to recap a little bit on what we learned before the holiday. So saya nak ingatkan, dia basically is about penggunaan formula. Okay, kalau dalam formula sheet kamu ada few formula that is given yang kamu pakai kat chapter ni lah, yang untuk subtopik yang atas ni. Number 1, V equals to F lambda, which is equation 49. Okay, and then yang tu adalah general formula lah, semua pakai tu. Lepas tu kamu ada F equals to NV over 2L, and then you do have another formula which is V equals to square root of T over mu. Okay, and at the same time you also have mu, which is equivalent to M over L. Okay, dulu dia tak kasih formula ni, so student biar cari mu tu dia terkejut. And then you also have over 4. Okay, so yang kita belajar lukis-lukis tu semua most likely tak adalah setiap kali pun kamu nak pakai melainkan diminta. Most of the time you just have to use the equation correctly. So this is the given equation. So which and which, number 1 kamu ada case bila kamu ada string. Okay, so for this string kamu pakai formula yang atas ni lah, yang pen ni. Jom satu. Okay, I think I'm gonna bring everything to the left. Okay, so yang odd tu, yang pelik tu, kita pakai untuk yang pelik jugalah, which is for open end tube. Sorry, close end tube. Sebelah tu tutup, sebelah tu buka. Tapi dia nama dia memang close end tube atau close end pipe. Close end pipe. Ni string, stretch string. And then kepada open end pipe. Okay, that one is the last one lah. Okay, untuk close end pipe ni dia yang paling pelik sekali. So bila pelik, end dia pun pelik. Okay, yang pertama yang pelik, yang pertama dia tu ni 2. Okay, in fact dekat bawah ni pun dia pakai yang 2 juga. Okay, untuk open end pipe they basically use the same formula. The only difference is this one, which is close end pipe, where you have a 4 over there. Okay, ingat kita cari ni F, frekuensi yang terhasil. Here and represent pempelik juga. 1, 2, 1, 3, 5 and so on. Only the odd number. Kalau yang untuk atas bawah ni, nombor dia macam biasa. 1, 2, 3 and so on. The only difference between the first one, stretch string, dengan open end pipe tu adalah equation ni. Okay. These two equation only exist on the string. Tension hanya ada bila ada string. Okay, ni mass of the string, length of the string. Okay, and then nama dia. And this one dipanggil sebagai fundamental. Okay, maybe saya buat table baru pun. So, kamu ada list of table like this. Fundamental. Maksudnya paling minimum. Macam ni lah. Satu tu je. Macam ni. Okay, kalau kamu naik, dia dah panggil first overturn. Naik lagi, second overturn. And so on. Okay. So, kalau kamu ada case yang number 1 and number 2 tu, kamu ada case yang stretch string dengan open pipe, close pipe, yang fundamental dia and dia sama dengan 1, and dia sama dengan 1. First overtone, nama dia first tapi and dia sama dengan second. 2 lah. The second overtone and sama dengan 3 and sama dengan 3. Basically you have to add 1. Okay. And then untuk yang tengah-tengah ni, fundamental is n equals to 1. Tapi sebab dia odd number, n sama dengan 3 and sama dengan 5. Faham ke tidak ni? Kamu masih bersama saya tak?
Faham, sir.
Faham Okay, and then fundamental ni dia ada nama lain juga. Dia ada nama harmonics. Okay. The fundamental one, they call this one as first harmonic. Okay. Second harmonic. And third harmonic. First, second, third. So you will see that if this is a second and sama dengan 2, third and sama dengan 3. So untuk harmonics, you just have to use the values. Masukkan je. Kalau overtone, yes, you have to consider lah. Kalau macam ni, first overtone and sama dengan 2. Second overtone and sama dengan 3. Cuba kita buat example. Macam 4. The tension in a stretch string of a length 1.5 meter, mass 9.1 gram is 1.5 kilonewton. Okay, kita keluarkan malam-malam. L sama dengan 1.5 meter. Length dia. Mass is 9.1, so I change to kilogram. And then 1.5 kilonewton ni apa? Simbol apa nak pakai? Newton, simbol apa? Cuba baca ayat dia daripada awal. Guys,
Force, F.
apa dia? Tak dengar?
F.
Okay, F sikit lagi. Dia sebenarnya adalah tension. So tension biasanya pakai simbol apa?
P.
T, tension. T, tension. Okay. Okay, the string vibrate in the fundamental mode. Fundamental mode maksudnya apa? And dia sama dengan and sama dengan berapa? Okay, kita nak pakai formula mana? Adakah kita nak pakai per 4L tu ataupun per 2L? Adakah 2?
Per 2.
Yes, per 2 Kalau per 4 tu untuk close pipe. Yang sebelah tertutup, sebelah terbuka. Okay, kalau macam ni, kita pakai 2 where and dia sama dengan nombor ganjil ke tak ni?
Tak.
Tak, okay, nombor biasa 1, 2, 3 and so on. Dia tak ada pelik-pelik. Ini yang biasa punya. So, if you want to use this formula, fundamental mode, maksudnya fundamental maksudnya N dia sama dengan
1.
1. Fundamental tu paling rendah. So, kalau ikut list ni, paling rendah adalah 1. Maksudnya. So, N is equals to 1. And the speed of sound, V sound, okay, they want you to find the wavelength of the sound wave. So, if you use this formula, yang atas ni, kamu dapat F. So, how do you want to relate F dengan V? V sama dengan F lambda. Okay, so the question want to find the V, you have to find the F first. Sorry, soalan dia nak apa? Soalan dia nak lambda, sorry. So, you have to find the lambda by using this equation. Tapi, nak kena ada F dulu lah. Okay, F tu kita pakai formula ni. Tapi ingat, V ni V apa? So, N tu sama dengan 1 kan? L dia sama dengan 1.5. Okay, V dia berapa nilai V? Adakah 330? Oh, adakah saya perlu kira lain value of V? Cepat guys.
Tak tahu.
Tak tahu. So, kalau untuk string, dia special sikit. Ni balik. Tengok kat sini. Dekat sini dia ada kasih nilai V punya formula. Okay, V ni adalah V untuk string dia. Berapa laju dia bergerak. Okay. So, it depends on the tension dengan mu lah. Contohnya kata dia tegang. So, T dia besar, V dia besar. Itu maksudnya. Kamu boleh bayangkanlah kamu petik gitar yang tegang tu kan. So, T besar, V besar. So, that one is V of the string. So, if you want to substitute inside here, you have to calculate the V lah. So, V here is equivalent to square root of apa tadi? T over mu. Okay. But remember, you also don't have the mu. So, you have to calculate the mu first. Mu here represent mass per unit length. So, mass is given, which is 9.1 gram. I change to kilogram. Okay, the length of the cable is string itu adalah 1.5. Dapat apa ni? I got here 6.067. What is the unit for mu? Siapa boleh teka?
Tak ada yang
Based on this formula, unit dia apa? Mass unit dia apa?
kg per meter.
Yes. So kg per meter. So sometimes in exam, they straight away give you the values of V and mu. So if you want to differentiate between mu dengan mass biasa tu, is that kalau mu ni dia ada per meter ni, M-1. Kalau mass biasa dia kg sahaja. So if you got confused, tengok unit dia. Okay, now that you have the mu, you can find the V lah. Tension is given, which is 1.5 kilo. Don't forget the kilo. Okay, you can calculate the mu, 6.067. So you already have the mu. And now you can calculate the V. Basically, this is the first step. This is the second step. I go backward to show you guys how it works. I got here is 497.23. Do you get the same answer ke saya salah tekan?
Sama.
Sama So hopefully kita on the right track. Now that you have the V, I can substitute back inside the Fn here. So it will be F1 lah. Sebab dia adalah fundamental. Kita substitute nilai N tu. So 1, V dia sama dengan 497.23 then divided by 2 and multiply with 1.5. So I got here F1 is equal to I got is 165.74. Is it correct?
Betul, sir.
Betul. Okay, now that I have my F, finally I can find my V. Sorry, bukan nak cek V dan cek lambda. So my lambda now, which is from formula up here, yang ni kan, lambda is equals to V over F. Okay. So if I use this one as my F1, then I will get lambda 1 lah. So tapi subscript ni kamu tak kira pun tak apalah untuk ni. Okay, so V sekarang ni nak pakai nilai apa? Adakah saya pakai speed of string tadi, which is this one, ataupun should I use 330? Dua-dua V. Cepat mudah lupa. Okay, now, let's see if you have the V. Kamu nak masukkan nilai V ni berapa? 330 lah kan? Kamu ada dekat dengan saya? Sebab apa? Sebab kamu sekarang ni nak kira lambda that is being produced by the sound wave. Okay, tadi tu speed of the string. Okay, now dah ada speed of the string tu. Kamu dah kira dia punya nilai frekuensi, masuk balik dalam ni. Okay, tapi sekarang kita pakai sound wave tu. Berapa ni dapat ni? I got here is 1.99 meter. You get the same answer with me?
Yes, sir.
Yes, sir.
Okay. Faham ke tidak?
Yang V tu sir, saya confused.
Yang mana yang V ni?
Kenapa?
V ni memang dia a bit confusing. Okay, paling senang nak ingat, paling senang. Kalau kamu nak pakai V dekat sini, for sure dia adalah V ni. Memang V ni. Okay. Tapi bila kamu nak pakai dekat sini, kamu kena pakai V speed of sound tu. Sebab dia dah cakap, determine the wavelength of the sound wave. So bila kita nak kaitkan dengan sound wave, kita kena pakai speed of the sound wave. Okay. Kalau saya masukkan speed of the string, basically saya kira lambda untuk string tu, bukannya untuk sound wave tu.
Okay, sir.
So paling senang nak ingat, kalau formula ni, V ni for sure is this one. Yang kalau nak pakai formula ni, V dia adalah 330. Okay. And then the same thing is a bit different compared to yang bawah ni lah. Sebab yang bawah ni, V ni terus 330. Itu yang special untuk string. So be careful with that one. Sebab yang ni dia tak ada string, dia memang sound wave je. So V ni terus 330.